Okay, let's talk about the part 9. Find equations of parallel lines. Find equations of parallel lines. So what kind of lines are parallel? First, let's see the definition. Two lines in the plane. We're talking about the line in the plane. In the plane, do not intersect they are called parallel. Okay, so you will see that two lines parallel. If you have a ruler, we believe two sides of the ruler are parallel. Maybe like this, even though when you draw the line, they are not parallel. It's just because you didn't draw it long enough. So for these two lines, they will intersect in some place because well, from this shape it looks they will intersect. Okay, so for the parallel, basically they have the same direction. Okay, so now let's see if we place two parallel lines in the same xy plane, the coordinate plane. We're looking for the equation of parallel lines, and we want to see what quantity controls this property. So for example, we have two parallel lines in the equation. Then remember that we have run, rise. You have a P and Q, then you will have a run and a rise. This is a run, this is a rise. Okay, and we can have similar one, run and the rise on the second line. This is L1, this is L2. It's a ST. This is a run and this is a rise. Okay, because this all the lines are parallel, we can see that actually this triangle, this right triangle is similar to this right triangle. So what we get is that the rise and the run, rise over run in the L1 and the rise over run in the L2, those two ratios are the same. They are both controlled by this angle, some trigonometric function of this angle. Okay, so those two rise and the run, first is from L1, second is from L2. Both are the slopes of the corresponding lines, right? So we see that if you want to have two parallel lines, you should have the same ratio about the rise and the run. In other words, you should have the same slope. Okay? You should have same slope. And here we are saying when you have slope. If you do not have slope, the other case, if two lines, this is y, this is x, L1, L2, if two lines are both orthogonal, then clearly they are parallel. So all orthogonal lines, all vertical lines, are parallel. All the vertical lines, here these two lines are parallel. If you draw another vertical line, it is also parallel to either of them. So all the vertical lines are always parallel. So when we talk about the characterization of the parallel lines, usually we just mean non-vertical lines. Okay, so we only focus on the non-vertical lines. And the theorem is called the criterion for parallel lines. Two non-vertical means we can talk about the slopes. Two non-vertical lines are parallel if and only if what? They have the same slope. Their slopes are equal and they have different y-intercept. Okay, so this condition, they have different y-intercept, just means those two lines do not coincide. We're really talking about two lines, not just one line with two different names. Okay, so the second condition, they have different y-intercept, just means they have to be different. Okay, so for example, here this is y-intercept, here this is y-intercept. If they share the same y-intercept, L1, L2 actually coincide, there's only one line. That's not interesting at all. Okay, so we are talking about two lines, two different lines. Okay, so usually when we say what is the condition for two lines to be parallel, we will say, okay, if they have the same slope, then they are parallel. Okay, two lines are parallel if and only if they have the same slope. Okay, so here actually we skip some important words, but that is something we keep in mind. First, two lines, two non-vertical lines. So this word we skip it. Still, we need it because we're talking about slope. So two lines means two non-vertical lines. Same slope, here we skip that they have the different y-intercept. Basically, they have to be two lines, not to coincide one line. Okay? So that's like the short description, but this short description should also contain some common sense. This is common sense. Non-vertical, different y-intercept, they are the common sense. Okay? Okay. Let's see the examples. So show that the lines given by the following equations are parallel. Okay, so how do we show it? So L1 is 2x plus 3y equal to 6. L2 is 4x plus 6y equal to 0. Okay, well, let's prove. We are going to use this theorem. We are going to check that if they have the same slope and they have different y-intercept, then they will be parallel. Okay, so solution. We will check that L1 and L2 have the same slope and different y-intercepts. Okay, so we're going to do this verification. Okay, so for L1, 2x plus 3y is equal to 6. We're going to write this. This is a standard form. We're going to write this standard form as a slope-intercept form. Okay, so what is a slope-intercept form? We move 2x to the right side, and divide the equation by the coefficient of y, which is 3. So you divide the equation by 3. Then y is equal to, remember that y is equal to mx plus b. The coefficient of x is the slope, b is a y-intercept. So the slope is negative 2 over 3. Y-intercept is number 2. Okay, so again, you have to include the sign. This is negative 2 over 3. This is a L1. L2, we do the similar thing. 4x plus 6y equal to 0. We're going to find the slope-intercept form and find the slope and the intercept separately. Okay, so 4x to move to the right side is negative 4x, and divided by 6, it's negative 4 over 6 times x is negative 2 over 3 times x. So you don't have the constant term. It means constant term is 0. So the slope is negative 2 over 3. Y-intercept is 0. You don't see it, it means it's 0. You add 0. So they have the, okay, so far what we got, the L1, L2 have the same slope, negative 2 over 3, and different y-intercept 2 and 0. So by the theorem, by the criterion for parallel lines, L1 is parallel to L2. Okay, so L1, L2, they are parallel. All right, so whenever you have two lines, you can determine if they are parallel or not. They share the same slope, they have different y-intercept. That's one type of a problem. The other type of the problem is the following example. Find an equation for the line that contains the point 2, negative 3, and is parallel to the line 2x plus y equal to 6. 2x plus y equal to 6. Okay, so basically you already have a line. You want to, okay, this is a line, and there's a point outside. You want to find a line parallel to the given line and through the given point, this way. Okay? Okay, so how do we do that? Since we know or we want to find the two parallel lines, the required line and the given line should have the same slope at least. Okay, so we don't know the slope of the required line, but we can compute the slope of the given line, which will be the slope of the required line. So we first find the slope of the line 2x plus y equal to 6. Well, it's not difficult. So you just move 2x to the right side. You will get y equal to negative 2x plus 6. Its slope, because the y has a coefficient of 1, so you don't have to do any division. So its slope is negative 2. Its slope is negative 2 here. So the slope of the required line is also negative 2. Okay, so we find the slope of this required line. And we also have the condition, this required line must contain the point 2, negative 3. Okay, it also contains the point 2, negative 3. All right, you have slope, you have a point, we have a point slope form. What is a point slope form? Y minus y1 is equal to m times x minus x1. So y1 is negative 3, so you get a y minus negative 3 is equal to slope negative 2 times x minus x quadrant 2. So this is the equation of the required line. Okay, this is the equation of the required line. Okay, and then let's, in the exam, okay, again, in the exam, this is the final answer. Don't simplify it. Don't simplify it, okay? In the exam, this is going to be the final answer. Do not simplify it. Okay, now let's provide the second way to compute it. Let's provide the second way to compute it. Two lines are parallel if and only if they have the same slope, they have different y-intercept. So one is y equal to mx plus b1, and the other one is y equal to mx plus b2. b1 is not equal to b2, right? So that's the criterion for the parallel lines. If we write them in the standard form, in the general form, so it is negative mx plus y is equal to b1, and negative mx plus y is equal to b2. We just move mx to the other side. So you will see that two parallel lines, non-vertical. Two parallel lines, actually they have the same left-hand side in the general form. They only have different right side. Okay? Two non-vertical parallel lines have the same left-hand side in the general form, but with different right-hand side. Okay, so now let's go back to this problem. This problem, we're talking about this problem. The required line should have the following general form. What is the following general form? It has the same left-hand side as this given line. So it's 2x plus y. It should have different right side. Right side, so far we don't know. We put b here for some unknown b. Okay? So it should have this form because it is parallel to the other line. Okay, so now our problem is to determine this B. What is this B? We are going to use this condition. The line contains the point 2, -3, which means the coordinates of this point satisfy the equation. So x is 2, y equal to -3. This pair satisfy the equation. Okay, so you just let x be 2, y be -3. So you have 2 times 2 plus -3 is equal to b. 2 times 2 is 4. 4 plus -3, 4 minus 3. So b is equal to 1. Okay? B is equal to 1. So the equation is 2x plus y equal to 1. Okay, so this is the second method to find the answer. Well, here you use slope point form, you get this one. Here we use a different strategy, we get this one. You can check that these two are actually the same. Let's try to simplify it. Y minus -3, let me copy it here. Y minus -3 is equal to -2x minus 2. Y minus -3 is y plus 3. -2 times x is -2x. -2 times -2 is plus 4. And you move this -2x to the left side, it's 2x plus y. You move 3 to the right side, it's 4 minus 3 is 1. So you see, that's the same thing. Okay? So it doesn't matter which method you choose in the exam. If you choose the first method, you should leave the answer like this. Don't simplify it. If you choose the second method, you leave the answer like this. Don't do any other transformation. All right? So is this clear? Okay. Okay, very good. Let's see the other. Okay, so now whenever you have a non line and a point outside line, you want to draw, you want to find the equation of the parallel lines, you are going to consult this example. Okay, there are two methods to apply. Okay. Okay, so parallel lines, two lines never intersect. Either they never intersect or they will intersect. In the case of intersection, there's a special position called perpendicular condition. Okay, so find equations of perpendicular lines. Okay, so this is a parallel. They never intersect, or they will intersect someplace. And sometimes they intersect in a nice way. This is always 90 degrees. And this is called perpendicular. Okay, so 1, 2 lines intersect at a right angle. Right means 90 degree. At a right angle, they are said to be perpendicular. Perpendicular. Said to be perpendicular. Okay, so this is perpendicular. Okay, so like the parallel lines, we want to find some criterion for the perpendicular lines. Okay. First, a vertical line and a horizontal line are perpendicular. Like this x-axis, y-axis, they intersect at a right angle, so they are always perpendicular. So you can put any other vertical line, horizontal line here. This is also perpendicular. Okay, so vertical line, horizontal line, they are always perpendicular. And this is a trivial case. We are not going to study this case. We'll study some other case when this line is not vertical, not horizontal. Okay? When this line is not vertical, not horizontal, we have this, and then let's see how do we get the condition. Again, we're going to use the property rise and run. Okay, so okay, now let's see. Well, this is run. This is rise. The same run, but the different rise. Let's put rise prime. Rise prime. Okay. We will see that in this place, I'm going to choose. This is a P. This is Q. This is R. In and S. And we will see that this triangle, the triangle QPS, this point, this point, and this point, and the triangle Q, this is the sharp point. This angle is smaller, so it corresponds to P, triangle P in this smaller one. QP, this P is a bigger angle inside this right angle, so it's R, PR. S is a right angle, S. These two angles are similar. These two triangles are similar. For the similar triangles, they have the corresponding ratios. So, for example, for this angle, the rise, the opposite over adjacent, rise over run, the rise over run, this angle corresponds to this part. Okay, let me make this angle corresponds to this angle. So it has the opposite. The opposite is run. Opposite is this part. Rise is adjacent. Okay, so whenever in the right triangle, let's make some difference. You have a right triangle. You have some other similar right triangle. When you get the corresponding angles, then the opposite over adjacent, the opposite over adjacent, it should be the same. The ratio of opposite over adjacent is equal to the opposite over adjacent. Okay, so here, actually, this vertical right triangle and this horizontal right triangle, they are similar. So you have the same opposite over adjacent, opposite over adjacent when we talk about this angle and this angle. Opposite means it faces this side. Okay, and then we divide this equation by run over rise, or we multiply two sides by rise prime over run. Oh, sorry. Rise prime over run. Here, when I do this multiplication, it becomes 1. Okay? you multiply this side by the same rise prime overrun. Be careful. This is a real rise. It's up, but this rise is down. It's negative. Okay, you see, this you're going down, the rise is negative. Here it's going up, the rise is positive. You always have one is positive, the other one is negative. So this is negative one. It's not a positive one. You have to be careful about the rise and the run. And then rise over run is a slope of the first line. Rise prime over run is a slope of the second line. So the product of two slopes is equal to negative 1. So this is a criterion for the perpendicular lines. Okay? So this process is not required, but this result is required. Because this process depends on the some trigonometry, which we don't have time to discuss yet. Okay, so the theorem, the criterion for perpendicular lines is the following. Again, here you have slope. Slope means they are both non-vertical. Two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. Okay, this negative 1 comes from one rise is positive, the other rise is negative. Okay? Okay, so if and only if you can get the product slope is negative 1, then two lines are perpendicular. If two lines are perpendicular, then the product slope is negative 1. All right, so that's a criterion. Okay, so clearly the simplest example is the following. If we have y equal to 2 over 3x plus 1 and y equal to negative 3 over 2, y equal to 3 over 2x plus 1, y equal to negative 2 over 3x plus 2, these two lines are perpendicular because those two lines are both in the slope intersect form. So the slope is 3 over 2, negative 2 over 3. 3 over 2 times negative 2 over 3 is equal to negative 1. Okay, it has to be negative 1. Be careful, it has to be negative. Okay. Okay, so after you understand this perpendicular condition, in the last part, when you have a slope, when you have a line and a point outside it, you can have a problem to find the equation of a line parallel to the given line. Or you can find the equation of line through the given point but perpendicular to the given line. So there's two possible ways. Like this is a screwdriver, okay? Okay, so that's the next example. The next example is the following. Find an equation of the line that contains the point 1, negative 2 and is perpendicular to the line x plus 3y equal to 6. All right, let's check. The product is -1, so if you divide it by, first of all, both of them can never be 0. If M1 is 0, the product is 0. If M2 is 0, the product is still 0. So none of these two slopes are 0. Okay, if they are not 0, so you divide the equation by M1, you get M2 is equal to -1 over M1. So the one slope is a negative reciprocal of the other one. So this is a condition you may use. Okay, it is a negative reciprocal of each other. Negative reciprocal. Negative reciprocal. Okay, so this line has a slope, and the required line is perpendicular to it. So it means the required line has the slope as the negative reciprocal of the slope of the given line. Okay, so we're going to find the slope of the given line, find the negative reciprocal. It is going to be the slope of the required line. Okay, so x plus 3y is equal to 6. We're going to write it in the slope intercept form to find the slope. So we move x to the right side, and we divide the equation by 3. Okay, divide the equation by 3. So the slope of the given line is -3, 1 over 3, -1 over 3. Its negative reciprocal is, so -1 over -1 over 3. You see, -1 over m, -1 over slope, it is equal to 3. Okay, so this is the slope of the required line. 3 is the slope of the required line. You have the slope, you have a point, then you write the point slope form. So the equation can be y minus y coordinate is equal to slope times x minus x coordinate, and that's it. In the exam, don't simplify it. From here, I can clearly see what is a slope, what is a point. All right, so that's the example. That is the example. Don't simplify. Okay. Okay, now let's see a different way to solve it. Let's see a different way to solve it. Okay, how do we solve it? Let's go back to the criterion. So two lines, non-vertical, two non-vertical lines are perpendicular if and only if the slope is the product of slopes is a -1. So you have a y equal to m1 x plus b1. m2 is here. Remember this, we have m2. And y is m2. m2 we just directly write a -1 over m1 x plus b2. Okay? So I don't care what a b1, b2 is. They may or may not be equal to each other. I don't care. I just care the slopes, because here the product slope is -1. So this is m2. Okay, so I don't want this denominator, so we multiply this equation by by M1. We just manipulate it a little bit. Okay, so we multiply it by M1, so this part is M1 times Y. Here's a negative X, M1. And then I'm going to move this to the left side and this to the left side. So we will get negative M1X plus Y equal to B1 here. X plus M1Y is equal to B2 times X1, whatever number you have. Okay, now let's see the left-hand side. I'm interested in the left-hand side. It's similar like the parallel lines. Left-hand side, first of all, they are different. They are different, but there's a pattern. Here is a M1, 1. Here's a 1, M1. You kind of interchange the coefficient. You interchange the coefficient. And you change 1 to be negative. So here's M1. It is negative M1. 1 is still 1. Okay? So you interchange the coefficient and change one of them to be the negative, to be the opposite sign. Okay? So that's the rule behind the observation. Now let's see how do we solve it. The given line is, where's the given line? X plus 3y equal to 6. The required line should be, okay, let's see how do I do it. I put 3, I exchange the coefficient, so 3x, x has no coefficient, it's a 1, y, 3, 1. I change this first one to be negative, opposite sign, and put b here. I don't know what b is. B is so free, I have no idea. I can only control the left side. I don't know what is the right side. So far, we will determine b later. Okay, so exchange the coefficient. Be careful, coefficient has a sign. If this is negative, you also move negative. If, for example, if you have this one, then you're going to move the negative 3 to x, and x has coefficient of 1. And the negative 3, you change it to be positive 3. Okay, so whatever you exchange the coefficient, you just change one of the coefficient to be the opposite sign. The other one you don't do it. The other one you never do it. You just change one. Okay. Okay. So here we have a unknown for some unknown constant. Unknown constant b. So this condition directly comes from the perpendicularity. There's one condition we still not used. It's the line pass through the point 1, negative 2. The line contains 1, negative 2. It contains 1, negative 2 means xy coefficient, xy coordinates satisfy the equation. So you get a negative 3 times 1 plus negative 2 is equal to b. Negative 3 times 1 is negative 3. Plus negative 2 is negative 5. So b is negative 5. b is negative 5. The equation is negative 3x plus y is equal to negative 5. Is equal to negative 5. Okay? So if you want, we can check this. Y minus negative 2. Let me check it here. Y minus negative 2 is a y plus 2 is equal to 3x minus 3. 3 times x, 3 times 1. 3x minus 3. And you move this negative 3 to the left side, 2 to the right side. It's negative 3x plus y, negative 3 minus 2, negative 5. So you see, that's the same thing. Okay? So this is the second method to find the equation of the line through the given point perpendicular to the given line. We always have two methods to solve the same question. One is about the parallel lines and one is about perpendicular lines. So you should practice both and try to handle at least one of the method. See which one fits you better. Okay, so that's this section. We finished this section. This section, especially this part 9 and part 10, they are more flexible. So do the exercise. It is very interesting. Sometimes it's creative, so you have to be able to solve them. Okay. Okay. We finished this section. We are going to talk about another curve in the next section, in the next video. Okay. Thank you.